Before time, before space, there was a point, infinitely small, infinitely dense, all that ever would be, compressed into less than an instant. An unimaginable state, waiting for the signal to begin. A cosmic seed, holding everything. Then, the bang. A silent explosion. Not an explosion in space, but an explosion of space itself. Energy unfurled, expanding at incredible speeds, racing outwards, creating the very fabric of reality. A universe born in a flash, a searing primal fire. A moment of pure creation. The initial inferno began to cool, slowly, ever so slowly. Milliseconds stretched into seconds, seconds into minutes. Fundamental particles formed from pure energy, protons, neutrons, the raw ingredients for everything to come. The universe was a swirling, chaotic soup of potential, still too hot for light to shine clearly through. Then, a crucial change. Atoms took shape. After hundreds of thousands of years, electrons were captured by protons and neutrons. Hydrogen formed, helium too. The very first elements. The universe became transparent. Light, for the very first time, could travel free across the cosmos. An ancient echo of this moment still whispers to us. We call it the cosmic microwave background. Darkness reigned for a time. But gravity, the silent architect, was at work. It began to pull matter together. Tiny fluctuations in density, growing larger and larger over hundreds of millions of years. The universe was not destined to remain empty for long. Seeds of immense structures were being sown in the dark. Patiently, gravity gathered its due. The first stars ignited, immense, brilliant beacons in the void, colossal balls of primordial hydrogen and helium. Nuclear fusion began deep within their cores. A new light shone in the vast darkness. These were giants, far larger than our sun. They burned bright. They lived fast. And in their fiery deaths, they forged heavier elements: carbon, oxygen, iron, the stuff of future worlds. These stars were not alone. Gravity pulled them into vast collections. Galaxies began to take shape. Immense islands of stars, gas and dust. Billions, sometimes trillions of stars bound together. Spirals with graceful arms. Ellipticals, like giant cosmic footballs. Irregular clouds of stellar light. Our own Milky Way galaxy, a nascent wonder, began its long, slow dance through the cosmos. These galaxies were not scattered randomly. They formed a grand cosmic web. Vast filaments and superclusters of galaxies, separated by enormous dark voids, an intricate architecture on an unimaginable scale. The universe was revealing its hidden structure, a tapestry woven from light and gravity, a testament to the fundamental forces that shaped everything from the very beginning. In a quiet spiral arm of the Milky Way, a giant cloud of gas and dust began to collapse, perhaps nudged by a nearby supernova's shockwave. This nebula, rich with elements from long-dead stars, swirled. It contracted under its own gravity, the raw material for a new star, and perhaps new planets. A new chapter was beginning. At the dense hot center of this collapsing cloud, a protostar ignited, our sun, a new beacon of light and warmth in our galactic neighborhood. Its powerful gravity began to shape the surrounding disk of leftover gas and dust, a star much like countless others across the galaxy. Yet, it would become profoundly special to us, the anchor of our future home. Within that swirling disk, planets began to form. Tiny grains of dust stuck together. Electrostatic forces, then gravity, growing into pebble-sized objects, then planetesimals, kilometer-wide bodies, then protoplanets colliding and merging. A chaotic, violent dance of creation. Rocky worlds formed closer to the young sun. Gas giants grew larger in the colder outer regions. Our solar system gradually took its familiar form. 8 planets, each unique. Countless asteroids and icy comets, each finding its stable orbit around our sun. A delicate gravitational balance was achieved over millions of years. A cosmic family, bathed in the light of its parent star. A relatively safe harbor in the vastness of interstellar space. A place where complexity could arise. Among these newly formed planets was Earth, a molten ball of rock in its early days, constantly bombarded by asteroids and comets from the chaotic young solar system. It slowly began to cool. A crust solidified. Volcanoes erupted, releasing gases to form an early atmosphere. Water, delivered by icy comets and outgassing from within, began to form the first oceans. A hostile world, yet brimming with potential. Then the miracle. Life's mysterious spark ignited, perhaps in warm little ponds or near deep-sea volcanic vents. Simple organic molecules combined. Somehow, they formed the first self-replicating life. Tiny, fragile organisms, yet incredibly tenacious. They began a journey of billions of years, the dawn of biology on a young planet. The most complex phenomenon in the known universe had begun. Evolution's grand tapestry unfolded, life diversified, it adapted, it changed. Through natural selection, it explored countless forms, from single cells to complex, multicellular creatures. Vast forests grew, strange creatures swam in the seas. Dinosaurs roamed the land for millions of years. Then, after a cataclysm, mammals rose to prominence. A story of survival, extinction, and constant transformation. And then, very recently, on the cosmic calendar, humanity arrived. We stood up, we looked up at the stars, we began to wonder. We developed language, tools, and civilizations. We are, in a very real sense, stardust. The carbon in our bodies, the iron in our blood, forged in the hearts of dying stars long ago. Our journey, from the Big Bang to this very moment, connects us to everything. We are the universe becoming aware of itself.